Hello, good morning all of you. This is Sanjay Talbar, Professor of Electronics and Telecommunication Engineering at SGGS Institute of Engineering and Technology, Nanded. Today's my lecture is on convolutional neural network and deep learning. Before going to the exact outline of the lecture, I would like to acknowledge researchers in the area of machine learning, deep learning and computer vision who have made their sources publicly available on the internet. Second, on online course, Machine Learning and Deep Learning Specialization by Andrew Ng on Coursera. I would like also to acknowledge Professor Fifi Lee and Andres Carpati for their online course called as a CS231 and Convolutional Neural Networks for Visual Recognition. I would like to also salute to the researchers in the field of neural network who got ACM's Turing Award 2018. First one is Professor Geoffrey Hinton from Canada, Professor Yashua Benjo from the University of Montreal, Canada, and Professor Ian Leakin, a French-American scientist at New York University, USA, and many others who explicitly cited. Outline of my lecture is what is machine learning application, traditional machine learning framework and flow. Then I will go to the introduction to the deep learning, brief overview of the neural network, basic convolutional neural network and popular CNN architecture with a framework and GPUs. Finally conclude with the discussion. Machine learning is the science of getting computers to learn without being explicitly programmed. This definition is given by Andrew Ng. Another definition is given by the Kevin Murphy. The goal of machine learning is to develop methods that can be automatically detect patterns in a data and then to use uncovered patterns to predict future data or other outcomes of the interest. The third definition is the field of pattern recognition is concerned with automatic discovery of regularities in the data through the use of computer algorithms and with the use of regularities to take actions. This definition is given by the Christopher Bishop. The applications of the machine learning starts with the optical character recognition, face recognition, surveillance system, autonomous cars and many more applications like political campaigning, predicting policing, filtering algorithm, recommendation engines, personal assistance, even including the healthcare systems. There is a small difference between artificial intelligence, machine learning and deep learning. Deep learning is a subset of the machine learning, while machine learning and deep learning both are the subset of artificial intelligence. Artificial intelligence is basically providing a intelligence or any technique that enables computers to mimic human intelligence using logic, if-then rules, decision trees and machine learning. While the machine learning is the study of algorithms so that a specific intelligence can be incorporated to the machine, while the deep learning, all machine learning algorithms are supposed to be implemented to the neural networks. The traditional machine learning flow consists of three steps. That is basically that is the two steps. One is the training and another is the testing. In training, there are three ingredients. That is the data which we want to use for classification purpose. We are supposed to extract the features from that training database and we are supposed to train the classifier model with the help of the training levels. While in a testing, we are taking a random samples from the training database which is kept aside and features are extracted and learned model is used to test the output and efficiency of the model is calculated. The traditional machine learning, as we have just said, there are two important things. One is how do you extract the features and how do you which kind of a classifier you are using. So minimum distance classifier, base classifier, SVN, Adabus classifier, neural network can also be used as a classifier with the backpropagation training algorithm for the multi-layer perceptron, random forest and decision trees. And there are a wide range of feature extraction methods, starting with the features based on first order statistics and second order statistics. newer features like LBP and ternary patterns, directional patterns, as well as the features which are extracted from the transformations, something like Fourier transform, cosine transform, wavelet transform, and Gabor transform. And the features nowadays which are popular is like SIFT, HOG, and textile. The deep learning consists of basically all these feature extraction as well as a classification task to be done only by neural network start from the end. There will be the few earlier layers which will be extracting the low level features. There are next few layers in the neural network which will be used for extracting the mid level features, and finally few layers will be there for extracting the features which are represented at higher layer, and then fully connected neural network used as a classifier which will be starting from the large number of neurons to less number of neurons. So the story of deep learning starts from the visual computing challenge started about 2010 where people have used the image classification challenge, or they have used basically the 1000 different classes and 14 million images were used, and challenge is called as a ImageNet large scale visual recognition challenge, where it is expected to give the better and better algorithms. Actual story, people given attention when in 2012 when Alex Krzyzewski presented his paper and his new algorithm or new system which have trained this classification algorithm by using a deep learning network, and very good results he has shown, and thereafter you will get lot many results in the field of image classification and segmentation. This ImageNet challenge or the ImageNet project was started at Stanford by Professor P.P. Lee and all others, and they have collected huge amount out of the database which is required for training the neural networks. Near about 22,000 categories data were collected with 14 million images, which includes animals, plants, structures, persons, scenes, outdoor as well as indoor sports activity, and mammals, different kinds of food and material, tree and tower, something like that. There are basically three ingredients required in the field of deep learning. That is, the huge amount of database is required which will be collected through the internet. Then high level computational engines will be required so as to train the neural network, and newer algorithms will be required so that these can be trained in a shorter duration. There are newer applications of deep learning, something called as the image classification, where image is a classifier based on the dominant object inside it. The bit difficult application is object detection and localization, where localize and classify objects appearing in the image. One more application is a semantic segmentation, where it is required to label each pixel on an image by object class that it belongs to, such as a human, sheep, and grass in above example. And last one is an instance segmentation. There is a possibility that there may be having more than one similar objects in the image. So how do you differentiate one object from the other object in terms of different labels? So there are number of challenges like illumination challenge is there, deformation challenge is there, the occlusions and cluttering and interclass variations there. So we are supposed to develop all the algorithm based on which will take these challenges into account. The brief overview of neural network. Neural network is basically inspired by the human brain, where it is a collection of a number of neurons connected to each other. Every neuron is nothing but a computational engine, where input is multiplied with the weights, and weights are randomly initiated or weights are initiated initially, and training of the network is nothing but finding the weight values Then a popular neural network architecture is evolved, that is called as a multi-layer perceptron, where number of neurons will be there in the input layer corresponding to the number of features, while the number of neurons in the output layer will be corresponding to the number of classes. And backpropagation algorithm is used to train the network, means the weights are calculated based on the backpropagation algorithm. Next. The convolutional basic architecture, we will ponder here on a basic convolutional neural architecture. A convolutional neural network is a class of a deep neural network mostly applied for analyzing the visual image. This convolutional neural network basically consists of the three subparts. One is a convolutional, then pooling and normalization, and finally it will be the fully connected or dense network used for the classification, or finally there is a classification where softmax can be used. The CNN makes use of basically the filters, which are also known as a kernels, to detect what features such as edges are present throughout an image. A filter is just a matrix of values called weights that are trained to detect a specific features. For example, if the image size is a 32 by 32 by 3, and we can use number of filters, size of each filter is a 5 by 5 by 3. The activation functions, different activation functions are used, starting with the sigmoid activation function, tan hyperbola, and recent activation functions as ReLU and leaky ReLU. The max pooling technology or technique is used to speed up the training process and reduces the amount of memory consumed by the network. We try to reduce this redundancy present in the input picture. There are a couple of ways we can downsample image, but most common is a max pooling. Next. Various CNN networks are evolved. The ImageNet project runs an annual software contest called as the ImageNet Large Scale Visual Recognition Challenge, where algorithms compete to correctly classify and detect the object scene classification. That is ImageNet challenge, which shows the top 5 errors. Case study. Let us have a quick view on one of the earlier network developed by Alex, called as AlexNet. AlexNet and then VGGNet. So let us have a highlight on a VGGNet. The architecture is proposed by Visual Geometry Group of University of Oxford. This network is characterized by simplicity, use only 3 by 3 convolutions and 2 by 2 pooling layers throughout the whole network. 2 fully connected layers, each with 4096 nodes, are then followed by the softmax class. Several variants of VGG nets are proposed in the paper, but VGG16 performs the best. The hardware used as a CPU and GPU. GPUs are nothing but thousands of small efficient cores for parallel processing, and the programming frameworks used by the industries are something like the Caffe, Torch, PyTorch, Theano, TensorFlow. Summary: the deep convolution network, where convolution, normalization, pooling, and fully connectors are used, and training of all these layers by backpropagation networks. Many specific enhancements are done, like a nonlinearity activation function is used, dropout concept is there, and lots of data and lots of computations are required, and newer networks like AlexNet and VGGNet and GoogleNet are proposed. Thank you very much.